Alright, question number 10. A lot of words here. So it looks like we do have two farmers, Farmers Brown and Farmer Jones. Jones and Browns. Okay. Farmer Brown built a rectangular pen for his chicken using 12 meters of fence. He used part of one side of his barns as one of the lengths of the rectangular pen. So he only has 3 lanes. Perfect. He maximized the area using the 12 meters. So he's gonna use the longer side of the pen as a barn to maximize area. Farmer Jones built a rectangular pen for his chicken using 60 meters of fence. Jones, okay. She used part of one side of her barns as well. The length of her pen was 2 meters more than the length of farmers. So the length of hers is going to be 2 meters more than Mr. Brown's. And then the width of her pen is going to be 1 meter more than Brown's. So let's go ahead and then draw two shapes so that we can see. This is Brown, this is Jones, okay? We know that they have this barn. I'm gonna call this one as a barn. Alright, and the same thing here. It looks like hers is a little bit bigger, and I'm gonna construct, okay, this is gonna be the width of what? Brown, and then this is gonna be the length of Brown. And the same thing happens here. This is gonna be the width of John, and then this is gonna be the length of Jones. But remember, the length of Jones is gonna be the length of Brown plus 1, and the width is gonna be the width of Brown plus 1. Now, what is the area formula? Well, area is given by length times width. So in this case, the area of Mr. Brown's pen is gonna be, the length is LB times WB. But we know that the fence is 12 meters long, and then hers is 16 meters long. So meaning that this plus this plus this is gonna be 12. So ideally what we have here is we got 2 WBs, right? So we got 2W plus length is equals to 12. So I can rewrite LB as WB. The same thing here, I can plug it, and the area is gonna be, area is equals to length times width, and the length is gonna be length of Jones times width of Jones, and again hers is gonna be 16. So we got 2 W of Jones plus length of Jones is gonna be 16. So I can rewrite length of Jones as 16 minus 2 width of Jones. So we're gonna use these two, and let me write this one. LB equals 12 minus 2 WB. Okay, these are what we're gonna use in here and in here. And then we're gonna get, if we go up a little bit, have more space, area of Brown is gonna be length of Brown times width of Brown, and length of Brown was given by 12 minus width, 2 widths of Brown. And then when we do the math here, WB times P, we got 12 WB minus 2 WB squared. This is the area of Brown. Now let's go ahead and then find the area of Johnson. The same principle, area of Johnson is going to be length of Johnson times width of Johnson. And then this is going to be, L is going to be 16, which is WB times 16 minus 2 WJ. I gotta do J here. Johnson. I'm mixing up Johnson and Brown. And then the next thing is going to be, we got 16 WJ minus 2 WJ square. Now this is the area of Johnson, but we want to write WJ in terms of WB, but we know that the width of Johnson is going to be 1 more than the width of Brown. That's what they say. So when we plug it in there, we get 16 times 1 plus WB minus 2 times, I'm running out of space, so I'm going to do that one right here, minus 2 times 1 plus WB the whole square. So ideally what we have here is, we got 16 plus 16 WB minus 2 WB square minus 4 WB minus 2. When we expand 1 plus W square, product of 2 square. And then 16 minus 4 WB will be 12 WB. 16 minus 2 would be 14. 14 plus 12 WB minus 2 WB would be the area of Johnson. So how much more is the area of Johnson? Well, if you look at it, I'm gonna circle this in red so that you can see it. This is exactly the same as what? This part of Johnson's area. So it's only more by 14 square units. So the answer for this one will be 14. There's definitely a short method, and I'm going to show you guys that in class. Okay, I don't want to ruin the surprise. Alright, this completes the problem.